Thank you for joining this lesson. Continue joining. I request you to subscribe to the channel and to also share the link with your friends. As communicated in advance, we're going to discuss simultaneous equations using several methods. There is the elimination method. There is also what we call the substitution method. There is the matrix method, and there is also the graphical method. So I believe you're going to keep in touch for the next few hours, which we are going to be together. Click the share button and invite a friend. Click the share button and have your friends joining us. Those who are still joining, thank you so much. Let me also invite some people. Yeah, thank you so much for joining us. You can comment and let us know whether you can get us clearly as we start our lesson. If you are hearing us, just give us a comment. Let us know that you can hear as well, that you can see my screen properly. Yeah, continue joining. Can see more people are coming in. That is very encouraging. Continue joining us. Yes. So we're going to discuss linear equations with two unknowns, and that is what is called simultaneous equations. Generally, simultaneous equations originate from some real-life situations which lead to formation of two equations. Instead of one linear equation, we have two equations being formed. Then that is why now we have to look for a way or ways of solving the pairs of simultaneous equations which arise from some real-life situations. Let me begin with a real-life situation here, whereby we are going to form and solve simultaneous equations. The first question is telling us that the cost of 3 t-shirts and 2 pairs of trousers is 600 Kenya shillings. If the cost of 2 t-shirts and 1 pair of trousers is 350 Kenya shillings, find the cost of each item. That is the cost of 1 t-shirt and the cost of 1 pair of trousers. So let us first of all form the equations. It's good to let the cost of a t-shirt be X shillings, and that of a trouser or a pair of trouser be Y shillings. So after letting these unknowns to represent the respective costs of a t-shirt and a pair of trousers, then we can now form two equations. That is a pair of simultaneous equations. 3 t-shirts and 2 pairs of trousers means 3 t-shirts, each costing X. When we add 2 pairs of trousers, each costing their known Y, are costing 600 Kenya shillings. Then the same items again, 2 shirts. So 2 times the cost of a shirt, which is X, plus 1 pair of trousers costing Y, shillings. This is supposed to give us 350 Kenya shillings. So this is now the pair of simultaneous equations, which is what we are going to solve simultaneously. There are numerous ways of solving simultaneous equations. The first one is the elimination method. Then we have the substitution method, and I'm going to follow the two of them. Let me begin by the substitution method. For me to use the substitution method, then I need to express one unknown in terms of the other from one of the equations. So for you to use the substitution method, let me write method 1, because we have to solve for y and x now. So let me write substitution method. Substitution method. Therefore, with substitution method, we have to express one unknown from one of the equations. Remember, this is equation 1. This is equation 2. Therefore, when you examine the unknowns, you discover that the unknown y from equation 2 is easier to express than y from equation 1, and also than x from either of the equations, because the coefficient of y is just 1. Therefore, we can say from equation 2, it can be concluded that y equals to 350. Then we subtract 2x. 350 minus 2x. So that is the expression of y from the second equation. So we can now replace it, or rather substitute it now in equation 1. So substituting in equation 1, we will rewrite it now by having 3x plus 2, and instead of y, now we substitute with 350 minus 2x. So 350 minus 2x, this is equivalent to 600. Therefore, now we can open brackets and have 3x plus 700 minus 4x equals to 600. Then with this now, we need to group like terms together because the unknown has been narrowed down to 1. We are only having one unknown, and that is x. So to handle one unknown, that is x, now we need to have 3x minus 4x, giving us negative x. Then on the other side, we will have 600 minus 700, giving us negative 100. So the value of x, when this negative cancels out, becomes 100. Therefore, the cost of a t-shirt, which had been laid to be x, is exactly 100. And now we can also talk about the value of y now. Remember, the value of y has been expressed at this point. So now we will go back to that point and substitute the known value of x such that y is equal to 350 minus 2 multiplied by the known value of x, which is now 100. So this will be 350 minus 200, giving us 150. Therefore, the cost of a trouser is 150. The cost of a t-shirt is exactly 100. So we have calculated the values of x and the values of y. Allow me to take you to another method, which we call the elimination method. So let me have some parking space on my right hand side here. Allow me also to copy down the two equations again, so that we may solve now using the second method. Continue joining our broadcast. Continue subscribing. Yes. So now we can look at the elimination method. The the elimination method, our second method for this case of solving linear equations. The linear equations are 3x plus 2y equals to 600. Then the second equation is 2x plus y. 2x plus y equals to 350. So for us to use elimination method, we have to eliminate one of the variables, and we do so by making the coefficients equal. For example, if we choose to eliminate x, then we are going to make the coefficients of x equal in the two equations. That is, we will have to multiply the first equation with the coefficient of x in the second. That is, we multiply the first one by 2 or through, then we multiply the second one by the coefficient of x in the first equation, that is 3. By the end of the day, we will be having the coefficients of x being equal in the two equations. So that means the first equation to be multiplied by 2 or through, and the second one by 3. So we're going to have my calculator. So we're going to have a 6x. Then we add for y. This is equal to 1200. Then after this, we can also multiply by 3 the second equation, which will give us 6x plus 3y. This is equivalent to 350 multiplied by 3, and this gives us 1050. Then after that step, what follows is a subtraction of corresponding terms, such that now we subtract in a way that if it is y's, we subtract y's with y's, x with x, and the constants with constants. So we start by 6x minus 6x, and that becomes 0. So x has been eliminated. Remember, it was our objective to eliminate x. Then the next thing now is to subtract y. So 4y minus 3y gives us y, and this is equal to 1200 minus 1050. This gives us exactly 150. So the value of y has been found to be 150, confirming the first approach. Then after this, we can now get the value of x by substituting y in any of the equations. If I substitute y in equation 1 or y in equation 2, I will get the same answer. Let me prefer substituting in equation 2. I will have to write 2x plus y, because this is the second equation, plus y is 150. So now we are substituting y. This is equal to 350. So at this point now, I can remain with 2x by saying that the value of the other side will be 350 minus 150, giving us 100. Then we remain with x by dividing through by 2, and we'll get the value of x being exactly 100, the value of y exactly 150. So that is how we solve. That's how we solve the pair of simultaneous equations. We can also have another example here. Remember, we are going to see the matrix method during this lesson, and we are also going to see the graphical method of solving simultaneous equations. We have another question here, number 2. Mora spends a total of 970 Kenya shillings on buying 3 textbooks and 5 pens. If she had bought 2 textbooks and 8 pens, she would have saved 90 shillings. Find the cost of 1 textbook. So in this case now, we're going to let, again, we can use some unknowns. We can let the cost of a textbook be T, Kenya shillings, then the cost of a pen be P. Those are all unknowns, and they are allowed when we are handling linear equations. You can let anything to be any unknown as long as you know what you are letting to be what. Therefore, Mora is spending 970 on buying 3 textbooks. So 3 textbooks, you can talk of 3T. When we add 5 pence, 5 by P, this is costing 970. This we can call equation 1. Again, if she had bought 2 textbooks, that means 2 by T, and 8 pence, that is 8 by P, she would have saved 90. So saving 90 means instead of spending 970, she would have spent 90 shillings less. That means 880. 970 minus 90 will give us 880. This is our equation 2. Now in this case, we are having the pairs, the pair of simultaneous equations, and now we have to proceed to solve. Allow me begin again by solving with the first method. We're going to use 2 methods in this one. Allow me use what we call the first method as substitution method. Substitution method. In this method, I said, and I'm repeating, that we just express one unknown in terms of the other unknowns from any of the equations. And according to the equations we have, it will be easier for us to express. It will be easier for us to express T in the second equation than expressing T in the first, or than expressing P from any of the equations, because the coefficient of T in the second equation is only 2. Therefore, 2 is a very rational number which divides a lot of the numbers that we have, and we can say the value of 2T equals to 880 minus 8P. So to remain with T, now we can talk about 440 minus 4P. This is from equation 2. So from equation 2, T equals to 440 minus 4P. With the value of T expressed, we substitute it now in equation 1. So we are going to rewrite equation 1, but now instead of T, we shall have this replacement. Therefore, I'm going to rewrite equation 1, which now becomes 3T. So 3, and instead of T, I'll have 440 minus 4P. Then I add 5P. This is equal to 970. Now in this equation, the unknown has been narrowed down to 1, that is P alone. I'm going to have 3 multiplied by 440. This gives us 1320 minus 3 multiplied by negative 4 becomes negative 12P plus 5P. This is equal to 970. Then now we can group like terms together. Negative 12P plus 5P will leave us with a negative 7P. This is equivalent to 970 minus 1320, giving a negative 350. Negative 350. Therefore, now we can talk about the value of P by dividing through by negative 7, where the negatives, first of all, will cancel. And after the negatives have cancelled, we will have the value of P as equal to 50. So P equals to 50 shillings. That is the cost of a pen. Then now we can go to get the value of T. Remember, T has been expressed. So for us to get the value of T, now we need 440 minus 4P, according to this expression here, minus 4P. Therefore, 4 the value of P has already been known. This will be 440 minus 200, and we will get T as exactly 240 Kenya shillings. Therefore, we have solved the two equations or the pair of simultaneous equations using the substitution method. At this point, allow me solve the same pair of simultaneous equations using the elimination method. Therefore, now we switch to elimination method. Remember to be very careful following up. There is a number already attached to this screen, and we'll be talking about it later. Remember to subscribe. Remember to share this link with friends. Continue inviting more people as we continue learning together. So let me write the two equations again so that I may solve them using the second approach, which is the elimination method. Now, let me write it even. Elimination method. So we are talking of elimination method. Equals to 880. We had already formed these equations. We had already formed the equations, and we are just moving on to solve them using the second approach. Sorry for the disconnection. Let me get back to you with my screen. Yes. Yeah, sorry for the inconvenience. Now we'll be talking about for the second method of solving them. That is the elimination method. Eliminate, we have to multiply. We have to multiply the two equations with the coefficients of the variable has to be eliminated. In this case, allow me eliminate the first variable to appear, that is t. That means the first equation will be multiplied with the coefficient of t in the second equation, that is 2. And the second one will be multiplied by the coefficient of t in the first, that is 3. So I'm interchanging 2 and 3 so that at the end of the day, the two equations will have equal coefficients for t. So I'm going to have a 6t plus 10p equals to 970 multiplied by 2, and this gives us 1940. Then the second one becomes 60 plus 24p. This is equal to 880 multiplied by 3, giving us 2640. 2640. At this level now, we are supposed to subtract downwards corresponding terms. Corresponding terms means if it is the t's, now we are going to subtract 60 minus, so I'm subtracting downwards now. 60 minus 60 becomes 0. Then we talk of 10p minus 24p, and that gives us negative 14p. This is equivalent to 1940 minus 2640. This gives us negative 700. So for me to remain with p, I have to divide through by negative 14, and that will give me positive 50. So p equals to positive 50 shillings. That is the cost of a pen. To this we're following. Then now we have to get the value of t by substituting the known value of p in any of the equations. Let me this time round substitute in the first equation, such that the first equation now becomes 3t, then plus t is 50 equals to 970. Yeah, equals to 970. Therefore, we'll now talk about 3t plus 250 being equal to 970. So I'll be taking 970 and I subtract 250, and this gives me 720. So 3t is equivalent to 720. So that the value of t becomes, when you divide through by 3, this will give us exactly 240. 240 Kenya shillings. So a textbook will be 240. Pen will be 50 Kenya shillings. So those are the respective values. Now at this point, allow me to talk about another question which will involve the matrix method. Yeah, another one now which will involve the matrix method. Remember to continue subscribing and inviting more friends. Remember to continue inviting as many friends as you can reach out to, so that we may learn together. This one now, it is the Form 3s and Form 4s to be very keen. The first thing we are told is to find the inverse. Find the inverse of the matrix. For us to find the inverse of a matrix, we have to first of all determine what we call the determinant of a matrix. So let me begin by getting the determinant of a matrix. Because we are not handling matrices, we are just applying matrices. I'll be very shallow on matrices, but the next time we'll be handling now matrices in details. So for now, we are just applying matrices. If it is calculation of determinant, allow me to go directly to the calculation of determinant, then application of determinant in determining the inverse, then application of the inverse in solving simultaneous equations. So now we will have the determinant, which is given by the difference between the product of the elements in the leading diagonal. So with this matrix, what we call the leading diagonal is the diagonal which runs from top left to bottom right. The matrix will have the leading diagonal having the elements. Yeah, this is the leading diagonal, 7 and 2. Those are the elements in the leading diagonal. So 7 times 2. We subtract the product of the elements in the other diagonal. So the other diagonal is having 4 and 3. So we have the leading diagonal and the other diagonal. The leading diagonal is also called the principal diagonal or the main diagonal. This will be 14 minus 12, giving us a determinant of 2. 14 minus 12, yeah. So the determinant is going to be 2. Now the next thing is to express the inverse. Assuming this is matrix M, then the inverse of matrix M is usually written as M raised to power negative 1 will be given by, when we divide each element by the determinant, remember to divide by 2 means multiplying by half. Therefore, we're going to have half, and we multiply each element, but there is a rearrangement which happens inside the matrix now. The elements in the leading diagonal will change their positions such that we will have 2 at this point and 7 at this point. Then at that point, the elements in the other diagonal will change their signs. So for the leading diagonal, they interchange positions. In the other diagonal, they change the sign. If it is a 4, now it becomes negative 4. If it is a 3, now it becomes negative 3. Then now we can open the bracket and have half by 2 giving us 1, half by negative 4 giving us negative 2. Then we will also have half by negative 3 giving us negative 1.5, and finally half by 7 giving us 3.5. Therefore, this is now the inverse of the matrix up there. Let us now proceed to the application of the inverse of a matrix in determining, in solving simultaneous equations. Use the matrix method to solve the simultaneous equations stated below now. 7x plus 4y equals to 14, 3x plus 2y equals to 8. So the first thing we do is to extract what we call a matrix equation. And a matrix equation contains three matrices. Therefore, we extract first of all what we call the coefficients matrix that will have 7, 4, then 3, 2. This is called the coefficients matrix. After that, we have the variables matrix. That is a x, y. It's a column matrix. This is equal to the constants matrix, which will be 14, 8. Therefore, this is called the constants matrix. The constants matrix. This one is called the variables matrix. The variables matrix. And the first one is called the coefficients matrix. This one is the coefficients matrix. So those three matrices make what we call the matrix equation. This is called the matrix equation. Now with the matrix equation, we can proceed now to solve the simultaneous equation. And what we do is that we multiply both sides of the matrix equation by the inverse of the coefficients matrix. And the inverse of the coefficients matrix has already been determined, because what we were working out in the first part is the inverse. Therefore, we multiply both sides by the inverse of the coefficients matrix. 1, -2, 1, -2, then -1.5, 3.5. This is the inverse of the coefficients matrix, and the coefficients matrix itself is 7, 4, 3, 2. Then we're just writing the equation now. We have multiplied the left hand side. We multiply the same. 1, -2, the -1.5, 3.5. We multiply this one now by the constants matrix, 14, 8. So now that is a step already done. We multiply both sides by the inverse of the coefficients matrix. Something that has to be understood is that when a matrix is multiplied with its own inverse, we usually get what we call the identity matrix. So a matrix, that is something to be understood, because on the left hand side we are not supposed to perform the multiplication of the matrices. We're just supposed to know that when a matrix is multiplied by its own inverse, we usually get the identity matrix. The identity matrix is a matrix which is having 1 as the elements in the leading diagonal and zeros elsewhere. Therefore, when the first matrix here is multiplied with the other matrix there, that is multiplying a matrix and its own inverse. So we don't need to perform the multiplication. We just have to write the identity matrix, which is 1, 0, 0, 1. So that is already given. We just imply at that step. Then now we multiply this by xy. This is equivalent to. Now we perform multiplication on the other side now. We perform multiplication. This is going to give us a, we are multiplying matrices. So we multiply this row times the column here. That is how matrices are multiplied. So we will have 1 times 14, negative 2 times 8. That will be 14 minus 16, giving us a negative 2. Then we have the other element by taking negative 1.5, multiplied by 14. Then we add 3.5 multiplied by 8. And this is going to give us exactly 7. So we have to multiply this row again with the column here. That will be negative 1.5 by 14, 3.5 by 8. And that is giving us exactly 7. Something else which has to be understood, any matrix multiplied by the identity matrix remains the way it is. Actually, the value of the identity matrix is 1. Therefore, multiplying matrices with the identity matrix does not change them. Therefore, now the matrix we are having here multiplied by xy will make the xy to remain the way it is, because what we are having is the identity matrix. This is equal to negative 2 and 7. And now we can conclude that the value of x is equivalent to negative 2 and the value of y equals to positive 7. Therefore, those are the solutions for the two unknowns that we are having in this case. We have another question here, which is talking about solve the following simultaneous equations using the matrix method. The first thing you must ensure is that the variables are aligned. For example, the first equation is negative 3y plus 2x equals to 7. But the second one begins with x, 4x plus 3y equals to 5. So the first thing will be, even before we get the matrix equation, we rearrange this pair of simultaneous equations such that we start with 2x minus 3y being equal to 7. Then 4x plus 3y equals to 5. Now the pair of simultaneous equations has been ordered well, and we can extract the matrix equation. The matrix equation will have, first of all, what we call the coefficients matrix. That means we will extract 2, negative 3, 4, and 3. That is the coefficients matrix. The variables are xy. Yeah, those are the variables. And this is equal to the constants matrix, 7, 5. That is a step already. The next thing is going to be determining what we call continue following. Can see members are joining us the more. This is encouraging. This broadcast will be saved here even after this, so you will be able to refer to it even later. You'll be able to refer to this broadcast. So continue following and sharing with friends. Continue following and sharing with friends. Continue following. Yeah. So now we can continue and have the determinant of this matrix now obtained. The determinant for the coefficients matrix. So determinant, we said determinant is given by product of elements in the leading diagonal. So product of elements in the leading diagonal, we have 2 and 3. At least people now have known what the leading diagonal is. So it is having 2 by 3. Then we subtract product of the elements in the other diagonal. The other diagonal is having -3 by 4. So this will be 6 minus -12, giving us a positive 18. Giving us a positive 18. Therefore, we have positive 18 as the determinant. Then we now have to determine the inverse of this matrix, whereby we divide everything by this determinant. To divide by determinant is to multiply with its reciprocal. Then we do some modifications in the arrangement of these elements, such that we have 3 taking this position, because the elements in the leading diagonal will change positions. We will have 3 taking the position for 2. This is what we call the leading diagonal. Those are the elements in the leading diagonal. So we will have 3 taking up the position up there and 2 going down here. Then we will have the other elements changing their signs. If it is -3, it will become 3. If it is 4, it will become -4. So that is it. Now we are having the inverse. We can even open the bracket and have 1/18 multiplied by 3, and that will be 1/6. Again times 3, 1/6. Then now 1/18 multiplied by -4. That is going to be -2 out of 9. -2 out of 9. And finally, we shall have 1/18 multiplied by 2. That will be 1 out of 9. Yeah, 1 out of 9. So this is now the final inverse of the matrix. With this final inverse now, we multiply with it both sides of the matrix equation. This is the matrix equation. The matrix equation. Therefore, now we need to multiply by this matrix both sides, such that we have 1/6, 1/6, then -2 out of 9, 1 out of 9, multiplied by 2 -3. Then what we have next here is 4, 3. So 4, 3. Then we have xy. This is equal to 1/6, 1/6, -2/9, 1/9. Then we multiply with the constants. Yeah, that is 7, 5. So we'll have 7, 5 at this point. So now on the left hand side, we don't work out a lot. We should be able to know that we are multiplying a matrix by its own inverse, and that gives us the identity matrix. So between the first matrix here and the second matrix, we don't need to perform any multiplication. We just supposed to write the identity matrix. That is 1, 0, 0, 1. The identity matrix is a matrix whose value is 1, and it is a matrix whereby the elements are 1 in the leading diagonal and zeros elsewhere. That is for a 2x2 identity matrix. This is equals to, now we carry out multiplication on the other side, multiplication of the matrices. We will have this row multiplied by the column here to give us the first element. Therefore, we will have a 6th times 7 and a 6th times 5 added. So 1/6 by 7 plus 1/6 by 5. This is going to give us exactly 2. Then again, we multiply now the other row here, the other row by the same column. So we shall have negative 2 over 9, negative 2 over 9 multiplied by 7, negative 2 out of 9 by 7. Then we add 1 over 9 by 5. This is going to give me exactly a negative 1. Make sure you are having your calculator to confirm these multiplications. At this point, again, we imply, and we'll be talking about when the identity matrix multiplies any matrix, the matrix remains the way it is because the value of the identity matrix is just 1. Therefore, on the left hand side, we shall remain with the variables matrix that way equals to 2, negative 1. And at this level, we can now conclude that the value of x is equals to 2, the value of y is equal to negative 1. So that is how we solve the pair of simultaneous equations. You can use the other two methods mentioned earlier to confirm the working. Remember, we are also going to see the graphical method of solving simultaneous equations. Yeah, remember to subscribe. I've said my number is already attached on the screen and we are going to talk about it. Meanwhile, it is the number that you'll be using to request for revision materials and to do further consultations. We have a number 5 here. Find the inverse of the matrix. Find the inverse of the matrix. So in part A, we are already provided with a matrix and required to find its inverse. It's good to know that for us to find the inverse of a matrix, we start by getting the determinant. So we get the date. The date of a matrix is given by the product of the elements in the leading diagonal. For this case, I'm just repeating again that the leading diagonal is the diagonal running from top left to bottom right. So that diagonal is having 5 and 4. 5 and 4. Therefore, with 5 and 4, we are going to talk about 6. Sorry for some disconnection. Let me get back to the screen. Let me take you back to the screen. Sorry for such a disconnection. Sorry. All right. So everything is now in order. Everything is now in order. So now we are talking about a negative 5 by 4 giving us a negative 20. Then we have 6. So 6 minus 20 will give us negative 14. So what we are calling the determinant is negative 14. Negative 14. Therefore, we are talking about negative 14 as the determinant. I believe you are still connected and following. Yeah. Thank you so much. People are still tuned. People are following very keenly. That is good. That is very good. Okay. Now we have the determinant as negative 14, determinant of the matrix. And with this now, we should be able to talk about the inverse now, whereby we divide each element. We divide each element by the determinant of the matrix. So to divide each element, now we are going to talk about going to talk about 1 out of 14, but it's having a negative. That is dividing with the determinant. Then now again we play with the numbers in the matrix such that 3 takes up this position and 2 takes up the position here. Then we'll have signs changing for 5 and 4, which were positive. Now they become negative. We can open this matrix and have negative 3 over 14 Then the next will be negative 1 over 14 by negative 5. So it will be positive 5 out of 14. Then on the lower row, we shall have negative 14 times negative 1 over 14 times negative 4. And that will be positive. So positive 4 out of 14, which means 2 out of 7. Then finally, we will have negative 1 over 14 times 2, which becomes negative 2 over 14, which is 1 out of 7. Remember, it's a negative. So this is now the inverse. This is the inverse of the matrix up there. Now we are going to apply this inverse in the calculation of the question thereafter. We are told that a transport company has two types of vehicles for hire: lorries and buses. The vehicles are hired per day. The cost of hiring 2 lorries and 5 buses is 156,000 Kenya shillings, and that of hiring 4 lorries and 3 buses is 137,000 Kenya shillings. Form 2 equations to represent the above information. So we are going to form 2 linear equations, then I'll transform them to a matrix equation. So the linear equations are going to be, when we are talking about the cost of hiring 2 lorries, we can let the cost of hiring a lorry be X and the cost of hiring a bus to be Y. So we'll be talking about 2 lorries. So 2 by the cost of X and 5 buses, each costing Y, to give us 156,000. Then again, that of hiring 4 lorries. So 4 by X and 3 buses, 3 by Y each, to give us 137,000. So these are simultaneous equations, and they have been formed to represent the information that we are having. We are also going to talk about now the matrix equation. This is a linear equation. The matrix equation which will be extracted will have 3 matrices. First, what we are calling the coefficients matrix, that is 2, 5, 4, 3. Then the variables matrix xy, this is equal to the constants matrix 156,000, 137,000. That is now the constants matrix. Yeah, so we have these are 2 linear equations, and what we have here is a matrix equation now extracted from the linear equations, matrix equation. So we usually form a matrix equation from 2 linear equations. Now we are taught to use the matrix method to determine the cost of hiring a lorry and that of hiring a bus. So now we are going to solve the above matrix equation now. What we should know is that the coefficients matrix we are seeing here is also the same as the matrix that we were finding its inverse in part A. That means now our work becomes easier because what we are calling the inverse is already determined. So we multiply both sides of the matrix equation with the inverse of the coefficients matrix. That will be negative 3 over 14, negative 3 out of 14. Then we have 5 over 14. Then we have 2 over 7 and negative 1 out of 7. This is the inverse of the coefficients matrix. Then we multiply now 2, 5, 4, 3. Then xy This is equal to negative 3 out of 14. This is 5 out of 14. Then we have 2 over 7 and negative 1 out of 7. Then we multiply by the constants now matrix 156 thousandths and 137 thousandths. Remember to subscribe to this channel. There are new members who are not yet subscribed. I invite you to be a subscribed follower to this channel. Something which is very easy to conclude is that when a matrix is multiplied by its inverse, we usually get the identity matrix. So on the left-hand side now, I'll be talking of 1, 0, 0, 1. This is the answer after multiplying the first matrix here and the second matrix here, because a matrix times its own inverse should give us the identity matrix. Then we have xy. We'll have xy. This is equal to, now I perform matrix multiplication on the right-hand side such that the first row is supposed to be multiplied by the column here. So I'll be having a negative 3 out of 14 multiplied by 156,000. Then I add 5 out of 14 multiplied by 137 thousandths. This is giving me exactly 15,500. So 15,500. The last element will be obtained by multiplying the second row that we are having here with the column of the constant matrix. Therefore, it will be 2 over 7. We carry out the multiplication, multiplied by 156,000. Then I subtract 1 over 7. That should be addition now, but it is a negative already, times 137 thousandths. This will give me exactly 25,000. 25,000. Therefore, it's again good to conclude that when a matrix like these variables matrix here xy is multiplied by the identity matrix, the answer is usually the matrix itself. A matrix multiplied by the identity matrix remains the way it is. So we shall have 15,500, 25,000. Therefore, we can now go directly to our conclusion that x equals to 15,500 Kenya shillings, and the cost of hiring a bus is 25,000 Kenya shillings. So these are the costs of hiring each vehicle. Yeah, the cost of hiring a lorry and that of hiring a bus. So it's already solved. Let us go to the last part of that question, which is talking of find the exact or find the value of x given that 2x minus 1, 1, x squared 1 is a singular matrix. It's good to know that a singular matrix is a matrix that has no inverse. A matrix which has no inverse. In other words, this is a matrix that has a determinant whose equivalence is 0. And because we know how the determinant of a matrix is obtained, then we will solve the equation and equate it to 0. We will say 1 times 2x minus 1. When we subtract 1 multiplied by x squared, we are supposed to get 0. That is the product of the leading diagonals elements, that is 1 and 2x minus 1, minus product of the elements in the other diagonal. And the other diagonal is having x squared and 1. That should give us a 0. So 2x minus 1 minus x squared equals to 0. Allow me arrange this equation such that I'll remain with a 0 on one side, or I will eliminate the negative on x squared. So I will take them to the other side and have x squared being positive, then minus 2x, and 1 becomes positive. Now we can have a 0 remaining on that side. We can solve this equation using many methods of solving quadratic equations, because now it is becoming a quadratic equation. And to solve quadratic equation, we can have the quadratic formula, the completing square method, the factorization method, etc., even the graphical method. Though in a simple working like this, you cannot exhaust yourself with a graph. So we can use the factorization method, whereby we need the product of two factors to give us a AC. That means the coefficient of x squared, which is 1, times the constant here, which is 1, and the sum of b, which is -2. Two factors which when multiplied give us +1, but when added they give us -2, are -1 and -1. Yeah, the product will be +1, the sum will be -2. So we can now replace -2x with -1 and -1. So this will give us the equation now, but re-expressed such that we'll have x squared minus x, then minus x again, plus 1, being equal to 0. So we factorize in the first two terms, x, which is common, 1 minus 1, then minus 1, which is common in the other two factors, minus 1, being equal to 0. Then now we can pick x minus 1, x again minus 1 equals to 0. Then we can talk about, because the factors are just the same, then we can say x minus 1 equals to 0. This is a perfect square, whereby after solving, instead of getting several values of x, we are having only one root. So the value of x is +1. Finally, we have a graphical question here. We are told to solve number 8 using the grid provided below. Solve the simultaneous equations. 3x minus 4y equals to 10, and 5x plus 7y equals to 3. Therefore, the first thing to do here is to come up with what you call a table of values. And a table of values will be better if we first of all express the equations in the form y equals to mx plus c. This one becomes very convenient, such that the first equation becomes 4y. When 4 is taken to the right hand side, then we will have equals to 3x minus 10. Yeah. Then now to remain with y in the first equation, we need to have 3 out of 4 x minus 10 over 4, which is 5 out of 2. This is the first equation. The second equation in the same format is going to be, we remain with 7y equals to 3 minus 5x, yeah, or negative 5x. Let me just have the same order. Let me not confuse you people. We will have -5 going to the other side. Then there is a +3 at that end. So the value of y equals to -5 out of 7x plus 3 or so out of 7. Yeah, plus 3 out of 7. Therefore, now we can talk about the table of values now. The table of values. Let me start with the first equation. Values of x and y. This is a table. You can also have another one here for the second equation. So in the first equation, we shall have values of x and values of y. Then we fill the table now. We fill the table. So we can start when the value of x is even 0. when the value of x is 0, the value of y is going to be negative 2.5, because when we substitute 0 at this point, when we substitute 0 at this point, everything there becomes 0. So y becomes negative 5 out of 2, which is negative 2.5. Yeah, we can also have the value of y being, let's say, 2. If the value of x is 2, we again substitute in the equation, and we'll have 3 out of 4 multiplied by 2, and that will be 3 over 2. 3 over 2 is 1.5. So 1.5 minus 2.5, this gives us negative 1. Negative 1. We can also talk about a third value and the last. The third value and the last. That is going to be, let's go to a value like 4. Yeah, when the value of x is 4, now we will substitute 4 in the first equation, and that will be 3/4 by 4, giving us 3 minus 5 over 2. So 3 minus 2.5, that becomes 0.5. So now we can plot this equation first before we do anything else. So we go to the graph and we plot the equation 0, 2.5. That is the first point. 0, negative 2.5. This is the coordinate. Yeah, 0, negative 2.5. Then the other coordinate is 2, negative 1. 2, negative 1. The coordinate is at this point. Then we also have another coordinate 4, 0.5. So 4, 0.5 is at this point. So we have 3 coordinates, and we can now plot. Our line. Can now plot our line. Yeah. So let me do my straight line now. Yeah, that is the straight line. The line, the first line, which I'm calling line. Let me go to the line. That is line 3x minus 4y. 3x minus 4y equals to 10. That is the first equation. We can now plot the second equation so that we identify the point of intersection, which will give us the simultaneous solution. Therefore, we can have values of x and y. Then the first case, we can have when the value of y equals to 0. When the values of y equals to 0, what will be the value of x? When we substitute in the equation, we will have a 5 over 7 now going to the other side. 5 over 7 going to the other side. That is we'll have 0 here equals to negative 5 out of 7x, which is a 0. Sorry, remember it is y, which is 0, and we have substituted. So we're going to have a x at this point plus 3 out of 7. So we will talk about 5 over 7x being equal to 3 out of 7. And when the fraction of 7 cancels, we will have a x being 3 out of 5. 3 out of 5 is the equivalence of 0.6. Therefore, the first value here is 0.6. We can talk of another value, like a value of x being equivalent to, let's say the value of x is 5, for example. Yeah, the value of x is 5. If we substitute in the equation, we are going to have the equation becoming y equals to negative 5 out of 7, 5 plus 3 out of 7. So negative 5 out of 7 multiplied by 5. Then we add 3 out of 7. This will give us a let me correct something. Negative 5 out of 7 into 5. Then we add 3 out of 7. This will give us exactly 3 and a 7, which is equivalent to 3.1. So the value of x will be the value of y will be 3.1. We can have the third value such that we substitute the value of x as another value, like we even have values of x now being negative, like a -2. Yeah. So with -2, we will be able to identify the value of y by substituting, such that we have -5 over 7, -5 out of 7 into -2. Then we add 3 out of 7. This is going to give me exactly 1.9. Therefore, the value here will be 1.9 to 1 decimal place. So when I plot this line, I'll be having 0.60. So 0.60 means 0.6 is at this point. So that is where the line is. Another coordinate is 5, 3.1. So 5 and 3.1. Now the coordinate is going to be at this point. Yeah, that is a 5 and 3.1. Again, we can also talk about -2 and 1.9. So -2 and 1.9 is going to be at a point here. So when you look at our coordinates now, we can see they are not even making a straight line. So we can check a coordinate like 5, 3.1. That is a coordinate to be doubted. Let me substitute it with when the value of x is 2 and when the value of x. So I'm going to replace this coordinate with coordinate 2. When the value of x is 2, what is going to be the value of y at this point? So the value of y is going to be -5 out of 7 into 2. Then we add 3 out of 7. This is going to give us exactly -1. So that is the coordinate now, which I'm going to employ. So I'm going to have coordinate 2, -1, and it's at this point. So I plot now my second line, which will be passing through this point. Yeah. So this one now is the second line, which is called the line 5x plus 7y. 5x plus 7y equals to 3. So that is the second line. Now the two lines have been plotted, and we can see they are intersecting at a certain point. They are intersecting at coordinate 2, -1. So this means because the coordinate is in the form xy, coordinates are usually stated in terms of xy. It means now if the two plotted equations had to be solved simultaneously, then their solution would have been x equals to 2 and y equals to -1. So that is the simultaneous solution using the graphical method. You just plot the two graphs or the two graphs on the same Cartesian plane, and you interpret their point of intersection.